welcome everyone to today's Synergist webinar, Better Root Cause Analysis Yields Effective Ergonomics Controls. I'm Kay Bechtold, Managing Editor of the Synergist, the magazine of AIHA. I'd like to thank everyone for joining us today, and especially Velocity EHS for sponsoring this webinar. Today's speakers are Rick Barker and Kristi Hames. Rick is Principal Solutions Strategist for Velocity EHS. He supports the development of software products that empower users to improve their safety, health, and ergonomics performance. Rick has achieved recognition as a certified professional ergonomist and certified safety professional. Kristi is Senior Solutions Strategist, Industrial Hygiene at Velocity EHS also. She supports the development of industrial hygiene and ergonomics software products that empower users to improve their health and safety performance. Kristi has achieved recognition as a certified industrial hygienist and a certified safety professional, and she is also a member of AIHA's Ergonomics Committee. And now I'll turn the presentation over to Rick and Kristi.
All right, thank you. I'm going to switch screens here real quickly. So today we are going to cover a couple things. A little bit on just the background of unsafe acts and multi-causality, just to get a kind of common framework for how we are talking about the whole idea of causes and controls for that. Then we're going to go a little bit into problem identification and then look at some approaches to root cause analysis and how we can use those in ergonomics. So just as some background on the whole concept of ergonomics and human factors and where it came from and how that relates a little bit to our process here of root cause analysis and the thoughts we're putting into it. So early human factors came really out of aircraft and pilots making errors. And so the original thing was, of course, that these are the pilot or the crew are making errors. And human factors dug a little bit deeper at that and said, well, why are these errors taking place? And those were really about the mismatch between the equipment design and the users as they were using it. And so this really forms the basis for how we approach the idea of the human as the cause in the system. And so we really don't see a human error or human acts as the root cause of either an accident or an injury. We look to the why that behavior took place in the first place. And there's a number of ways that we can look at that and break that down. But the key point is what creates our condition here. So if we just kind of back up to the idea that's very prominent that things are based, that incidents are based on unsafe acts occurring. And this is really a little bit of a misnomer because depending on how we classified the activity that we just saw, we wonder, is it an unsafe act? So we could sit there and say that there was improper lifting technique to bend over and lift out of this box, but there's no way to use proper lifting technique to bend over and lift something out of a box. They didn't seek assistance. It could contribute to it, but it's still at the bottom of the box. So the next couple really get us a lot closer and away from the acts and more into the mismatch between the human capability and how we've designed the task to be performed. So one of them would be that we didn't provide the right type of a lifting equipment, or we delivered this in a tote or a box rather than open on a pallet where they could get to it more easily. So how we classify things, so if we look at, people saying 80% or 90% of these incidents are based on unsafe acts, we can quickly see that a lot of it came down to how we classified things in the original incident report. And this comes down to how we approach the whys. on this. So we could ask the whys of why is there this bent back posture? They're bending over to lift the item. Why are they bending over to lift it? Well, they're using improper lifting technique. They shouldn't be bending at the waist. Why is the person using improper lifting technique? They didn't follow the instructions in our training. It's been too long since training. They didn't take the training. We didn't provide efficient enough or frequent enough feedback. All of those could be factors, but if we fixed those, we'd be fixing the wrong things. So if our problem is that we didn't provide enough feedback, our supervisors are going to perform more observations. Maybe we're going to get wearable sensors, and the item is still going to be in the bottom of that tote. Whereas if we looked at the other and we said, hey, it's on a fixed height delivery cart, it's too low and retrieving from the two lowest levels, we could raise the delivery cart, we could reduce the number of layers on the cart, or we could provide an adjustable height cart. So we'd be changing the equipment, we'd be moving to engineering controls rather than relying on work practices type controls. The other baseline element that I'd like to talk about is emphasizing when we're doing root cause analysis that nearly everything is multi-causal. So it's not that we're trying to get to that one single cause. We're trying to get to the underlying causes that if we address those underlying causes, we could prevent it from occurring. So let's take something like an automobile accident. There could be a case where it's a combination. Somebody's driving too fast. They're talking on the cell phone while they're driving. There's poor visibility, and they had bald tires. Well, any one of those not being the case might have prevented the accident, but all of those were factors that were involved in the causality, and we may want items to address each one of those factors. So as we move from the kind of common understanding to the process that we're talking about, whenever we're looking at identifying our controls, before we get to the controls that we want to put in place, we need to understand the causes. And to understand the causes, we really need a clear definition of the problem. So when we're doing that clear definition of the problem in ergonomics, whether we are responding to an incident that already occurred or whether we're trying to work in a more preventative manner, there are a few common steps that we can take. So the first one is observing the work. We'd move on to conducting good operator interviews. Building a process map is really useful in this. And then what risk assessment methodologies we might use and how we take information from those risk assessment methods to more clearly define what the problem is. So no substitute for getting out and being in the work area with the people doing the work. And so some of the things I'd like to talk about as it relates to effectively interviewing the operator and gaining information about the problem from the person doing the job. The first one is really more about a mindset, and that is when we're going to gather this information, it's appreciating that the person who does this job brings an expertise about that job that no one else has. I may know a whole lot more about ergonomics than they will ever know, but they know a lot more about that job from doing it day in and day out. And my goal is to learn from them. And just thinking about it in that way changes the type of questions that we think about asking, the follow-up questions that we would add on to those, and really our whole interaction with the person that's doing the job. So these are just some example questions. It's really about exploring what the situation is. So one of the things that I'm always trying to find out as I'm doing the interview in the job is, okay, so I'm seeing some of the common standard steps in the process, but when are there departures from there? How do some of the things that I see would have to happen, but aren't occurring right now taking place. So, for instance, oh, you're pulling parts from a parts bin. How do those parts bins get restocked? And maybe there's a material handler or a water spider who does the stocking of parts, but are they always available? And what happens when they aren't available? What about machine jams or parts being out of spec? Some of the other things that I like to find out about are just aspects of it that I might not be able to see right now today. So um, perhaps it's product variation. Are there some product variations that are harder to assemble or harder to build than others? Um, Another one that's really useful is understanding what aspects of the job are physically difficult to do. And not everyone will share that with you directly with it. So you can ask this question in a number of ways. Um, so one that I've found useful is to ask, if I could do one part of your job all day for you, what would you select? And why would you pick that one? And so it gives a lot of insight into what things are hassles or difficulties in the job. Like to find out what they're interested in trying, what they've tried in the past and didn't work. So all of those are good avenues to explore just to help understand what that process is better. Through that, and as part of that, I'm also building a process map. Now, I may already have a process map as part of a job safety assessment or the work standards that exist for the job. And so that tells me about what's planned. But I also want to learn from the person doing the job about the actual. So this is a real life case from a blender loading operation. And the piece that was the most difficult was one where there was one material that would cake up and harden, and they needed to break it apart before they did batches for certain products. So wouldn't have seen it all the time without asking. And breaking apart the clump material, the little sketch there of it doesn't do it justice. The person took the box or fiber drum, depending on which one it was delivered in, and they raised it up to about shoulder height quickly, and then threw it down at the floor 3 or 4 times to try and get it to break apart enough that they could then use a hammer and pound on it to break it apart even more to weigh out the correct amount. So without understanding the actual element that took place in this process, the things we would have fixed wouldn't have gotten at the largest risk exposure that was occurring in the job. So then when we move on to the risk assessment methods, when we're doing a risk assessment in ergonomics, there are a few things that risk assessment is useful for telling us. Certainly, it's useful for telling us about the likelihood of musculoskeletal disorder in that situation. It's also going to help us prioritize some of our intervention plans, and it's going to help later verify that the improvements either that we're planning are going to address the risks, or that when we put them in place, they really accomplished what we had planned to do. But the one that I skipped over there is the one where we're going to be spending the remainder of this webinar talking about, and that is as a way of helping us to understand the risk factors that exist within the job. So by looking at these factors, we can either help identify what may have caused an injury or what is creating an increased likelihood of injury in that job. And different tools are going to give us different quality of information that we can leverage there. And it's one of the things that I encourage people to consider as part of what they're using for criteria in selecting which risk assessment tools would be appropriate for a given situation. So I'm just going to look at a couple examples here. So looking at the Liberty Mutual equations and some of the things that it could tell us in material handling. So we have some inputs, and all of those will tell us about things like the frequency at which it's occurring, the distance of the travel, the weight of the object, and will give us an output. Um, the output on this doesn't help us as directly identify what the causal factors are on that unless you know the workings of it pretty well. The easiest way to do that is to go in and play with some of these numbers and see how they would change it. And then you can see a little bit of which the factors are that are having the biggest impact. I'll contrast that to using the NIOSH lifting equation. And I particularly like outputs of the NIOSH lifting equation that will give us what the multipliers are so that we can identify which components of that lifting equation were having the biggest impact on the lift itself. So I can go in and determine that, oh, the horizontal multiplier was what was the biggest impact on the overall recommended weight limit. And as a result, if I can change the horizontal, that's going to be my biggest opportunity for improvement. So it's going to lead me to focusing on the horizontal as the cause rather than necessarily what the grip is like on that job. So when we move to assessments of the whole body, I have assessments from a couple different options here with that, including one of our own products with it. But being able to break out by even just which body areas we're focused on can be a big factor in helping us target where the causes are. So if I look at the top graph at where it identifies the amount of time in an awkward posture for each one of the body regions, I can quickly identify there that the left and right elbow and the neck are the main factors that are going to be high risk exposures in the task that I'm going to look at. So I would then focus my attention on elbow postures and neck postures in order to bring down the overall risk score for that job. In the examples on the bottom, these are a couple things that would give us a little bit more breakout. One of those visually, which would tell me that looking at the upper limbs, particularly the shoulders and elbows, are going to give me the biggest impact. And the one on the right side of your screen would break that impact out even further and say, beyond just which body regions to look at, what aspects in those body regions. So in all of the cases here, the body areas that are highest risk, it would be the forces and, at least for some of those, the postures that were involved. So I'm going to pull that information forward into some of the root cause analysis methods. And as we go through these methods, the methods that we would use for looking at it as a risk factor are really the same methods that you've probably used many times for investigating incidents or used in your quality programs. This is just a way to take that same approach and apply it to the risk factors themselves. So Kristi, if you'd like to take over.
Sure, thanks, Rick. The first thing we're going to look at is a fishbone diagram. And probably many of you have used these before, if not in safety, maybe for quality. And here's an example of one that would be used in quality, where they would look at things like measurements, materials, personnel, environment, and machines. And we can actually take this and apply it to ergonomics and replace the terms there with more ergonomic focused terms. If you wouldn't mind switching the slide, Rick. There it goes. So we can take this and actually, when you're looking at our risk assessments, we can take the body parts and put them on the fishbone. So we would have our problem statement in the middle, and we can look at, hands. Where are we seeing issues with hands? Elbows, shoulders, the neck, the back, and then also the legs. So, when we're going to use this example here. So let's start with, here we have our mannequin that shows we have the shoulders and the elbows and the back that are higher risk. It has a high risk score of 30. So we want to put on our fishbone, the worker is exposed to a high level of MSD risk, and then we have the body parts that would be affected for high level of risk. So we're going to say that would be the left elbow, the back, the left shoulder, and the right shoulder. And then looking at the graphic at the bottom, we get a little closer view of what could be causing that high risk for that body part. So for example, with the left elbow, we're going to see that force as well as posture are contributing to that. The same for the left shoulder and the right shoulder. And then with the back, we have an awkward posture that's giving it a higher risk. So from there, we want to look at what are our process steps. So this is where we go back to that process map that we created, and we look at all the steps that the employee could be taking. So in this case, this is an operator who does all of these steps. They climb a tower, they move a gangway, they remove a cover for the gangway, they move a load arm, they secure the cover back in place, they move the gangway again, they move a hose, they connect a hose, and they replace air bottles. So we're going to want to look at each one of these process steps and which forces affect which parts of the body to see if we can get closer to the root of what's going on. So if we're looking at the left elbow, for forces, we're going to say things with high forces on the left elbow, those would be moving the gangway, moving the load arm, moving the hose, and then also looking down at the left shoulder and the right shoulder, moving the gangway, that's a high force for those as well. So the next step is we want to look at the moving the gangway and see what we can look at each one of these tasks and see what we can come to as far as improvements for each of them. So I just mentioned moving the gangway, that's the top right. So some of the contributing factors here could be the angle of the force application. There could be some friction in the pivot. Maybe there needs to be some maintenance done. It could be the length of the gangway. Maybe it's too long. The load arm hangs up on the gangway. And then there's a lack of powered equipment, so there's a lot of manual work contributing to those forces. And then also the weight of the gangway. Maybe the gangway is too heavy. And this, along with things with moving the hose is heavy. The lever arm has a long reach distance to the hose. If changing out a fresh air bottle, we would have a cart design that maybe is ineffective and causes high forces for the operator. Looking at moving the load arm, maybe it has a handle, but there's poor handle design, and that causes extra forces. So all of these things could be contributing factors that are leading to high forces for the operator. And then we can take that and expand that out even further. So one thing I do want to note that if you have a space with a really large whiteboard, all of these could actually be put on one large whiteboard, and you just keep breaking each one down. You have a lot of little branches and a lot of trees. We don't have that. So because of that, we have each of these in separate slides, and you could also do that as well. If you don't have a large whiteboard space, it could all be done in PowerPoint or something similar where you have one slide or one page per element that you're looking at. So now we maybe want to focus on that gangway, and that's going to require them to exert high forces. So, what things are contributing to the high forces with the gangway? And as I mentioned on the previous slide, we're going to have the length of the gangway. And then we want to look at, well, why is that? Well, there's apparently no reason for the current length. So maybe that's something that can be fixed. We have the weight of the gangway. Maybe it's the materials of construction. Is there anything that we can do about the weight of the gangway? We could have some friction in the pivot point. And we can look at, well, what materials are used in that. And also, what PM has been done? When has the preventive maintenance been done? Do we need to do more preventive maintenance? Why hasn't it been done in so long? It could end up that the load arm is hanging up on the gangway during the movements, and we find out that there's no home position for the gangway. There could be a lack of powered equipment, and the reason why is it's a corrosive environment and we can't use powered tools. And then the last could be another thing contributing to the high forces would be the angle of force application. Why do we have that? Maybe there's an attachment point on the strap. Maybe there's no pulley, which would lead to it as well. So that's the fishbone. And the next one I'm going to talk about is a 5Y, which is probably more commonly used by us, not just in ergonomics, but in health and safety as well. And what we do with the 5Y is you're going to define the problem, And then you ask a series of why questions, good why questions. So in this, you're going to have your problem and you're going to have a why question about it. And there will be an answer. Sometimes there will be a countermeasure associated with that answer. Sometimes there won't be a countermeasure. So you'll take that first answer and you'll ask, why about that? Well, why do we have this then? You'll have an answer. You maybe will have some countermeasures. And you keep going on until you have, your countermeasures will eventually lead to some direct causes of things that you could fix. And once you get to the bottom of it, you'll eventually find the underlying factor that would be your root cause that you could use then to help prevent these things from happening in the future. So I'm going to go through an example from a different assessment. And we're going to say in this example that maybe we found the area of highest risk is going to be the back. So we're going to say, okay, well, what contributing factors could cause the back to be high risk? And we're going to find out that maybe it was force and duration. So we're going to go down both sides of this. For the sake of time in the example today, I'm going to focus on force. But once you were done looking at force, then what I would naturally do is then move on to duration and answer all the questions for that as well. So for force, we're going to say, okay, well, looking at our process map, what subtasks have the greatest exposure to this risk factor? Well, it ends up that we move a cart into position that results in high force, and then we also change roles, and there are high forces with that. So going on from there, let's look at moving the cart into position. Why does the risk occur in this task step? Why are we having a force issue with moving the cart into position? Well, the cart is hard to push. Okay, well, that's good to know, but why is that cart hard to push? Well, it ends up that the casters are too small. So there's one of our direct causes. The casters are too small. The countermeasure could be that we need to get different size casters, and we'd have to do some research on that to see what the right type of casters would be. And then also one of the answers could be, well, the floor is uneven. And a really good question, the next question is, well, why is the floor uneven? And the answer to that maybe is there's been a lack of floor surface repair. So a countermeasure for that would be we need to do more PMs on the floor and get the floor fixed so it's a level for surface. I did see a question pop up asking why we limit it to 5. That's a really good question. It doesn't necessarily have to be 5. It might take 3 questions. It might take 10 questions to get to the bottom of things. And the point is that you just keep asking why until you get to something that's actionable, that you have a direct cause, and then eventually your root cause, and you can act on it and implement some improvements. Continuing looking at force, we're going to ask, the changing the roles. Why is there a risk that occurs in this step? Well, the roll is too heavy to lift manually. Well, why is that? Well, there's no lifting device available. And the next question would be, well, why don't we have a lifting device? And that would be something we could act on, is to look for, do some research on what type of lifting device we would need. So we would continue that on for anything that contributes to force, and then also do the same thing on the right for duration. And I'm going to hand it back to Rick to wrap things up.
Okay, so the final one that I'm going to talk about is probably the least frequently used of these, but one that can be relatively valuable as well with this, and that is it's called the interrelationship digraph. And the process that you would do for this is you would have your team together and brainstorm what the contributing factors might be. And then you take all these factors and you place them in a circle, and you draw arrows between the different factors. Now, this requires having people gathered together that understand the process really well. So it's a great way to involve operators and engage them in the activity that's going on. And so for each pair of boxes, what we'll go around and do, and I'll show this in a second here as an example, but we'll ask if there is a cause and effect relationship with it between these two. And if so, what direction of that relationship is stronger? And so we'll go through each pair of boxes, we'll draw those arrows in, and when we get done, we'll just count up the arrows that are going away from each box and going into each box. And as we find the boxes that have the most arrows going out of them, those are going to be the boxes where we have the most opportunity to impact from a causal standpoint, break the chain. So this is actually the same task that Kristi was just looking at in the 5 why. And it's looking at one aspect of that task where this looking at employee is spending too much time bending over during layup. And that's what's causing the duration of the awkward back postures. And so we brainstormed the different reasons that could be factors there. The table's too low for applying tension to the fabric because, for the layout process, you have a certain amount of tension on it. The fabric is stored too low. There's no hoist available for lifting the roll from storage. The fabric requires constant tension. The tensioner is broken. And the fabric is too wide for one person to apply all tension to it. So we start out and we look at how the pairs relate. Starting with the table is too low, which ones relate to that? Well, the fabric requiring constant tension is related to having to apply tension to the fabric, as is the tensioner being broken. I just moved around it clockwise and looked at the next one where the fabric is stored too low. Well, one thing contributing to that is the no hoist being available. We continue around the circle. We start adding in the other pieces to it, and we end up with our counts in the different areas. And so as we look at these counts, the number of arrows of any one is the one that we wanted to focus on as having the most opportunity for impacting all of the other causes. And so what this identifies for us is that the tensioner being broken impacts the fact that the fabric is too wide for one person to apply tension because the person doesn't need to apply tension if the tensioner is working properly. The fabric requiring constant tension, well, it does require that, but if the tensioner is working, the person doesn't have to do that. And the table is too low for applying the tension to the fabric. Again, if the tensioner is working, then the height of the table doesn't really matter as what's happening with the person for that. So it gives us a way to quickly see which area for change is going to have the most immediate impact on all of the other elements. It doesn't mean that, providing a hoist isn't a good idea. It doesn't mean that perhaps raising the table isn't a nice short-term fix for it, but it does help get us at what we should be focused on in the longer term to have the biggest impact on the overall risk exposure. So with that, we are a couple things. If you want to scan the QR code, you can use that to request more information, request a copy of the presentation, or any other aspects you would like there. So we'll have that, and we'll also now open up for questions.
Okay, great. I think, could we possibly put the QR code back up?
Yes, let's do that real quick.
Okay, great. Thanks, Rick. Okay, great. I see it now. Hopefully everyone can see that. Also, the QR codes where attendees can request copies of the slides and things like that. So that should be up on the screen now. I wanted to thank Rick and Kristi for your presentation. We have plenty of time for questions. So just a reminder, if you'd like to ask a question, please type it into the chat window on the right side of your screen and send it to everyone. The first question I have for you all is a bit of a two-parter. Is there really a single root cause, and what is the root cause of not having an adverse ergonomic situation?
Okay, well, I'll go ahead and tackle that. Tackle certainly the first part of that one, and that is that um, rarely are we diving down and finding that there is one and only one root cause. As we kind of saw through breaking out the 5 why analysis, there were different aspects that were contributing to the event and or the risk factor, whichever it was. And we have to track down each one of those avenues. So there's lots of times we're going to ask why, and there's going to be several reasons why for that. And we need to explore each one of those to get to all of the aspects there. But that's also where something like that interrelational digraph can help out, is when we have multiple causes, which ones are going to help us have the largest impact. Now, can you repeat that second part of that question? I was a little unclear what you were saying with it.
Sure. Sorry about that. The second part of the question is, what is the root cause of not having an adverse ergonomic situation? I guess the questioner, if there is any other information, I can keep an eye on the chat to see if there is a clarification there.
Well, I'm wondering if that one, if the questioner was asking more from the standpoint of an incident related to ergonomics. And what we've been talking about in the talk today certainly can be used when we have an incident related to ergonomics. It can also be done when it applies when you're doing a proactive ergonomics risk assessment, where you're trying to reduce risk in the workplace and prevent those incidents from happening further on down the road.
Okay, I see the clarification here now, asking, what if there truly is no root cause with it? And there are going to be some causal factors. Now, they may be personal factors in it. It might be, we take the example of hearing loss all the time, and I play in a rock band and I don't wear hearing protection. And so there wasn't a work-related cause for that, but there was still an underlying cause that took place. So, all right, some of the other questions. What type of process maps are used or usually used? So process maps can end up being very, very detailed or be very high level and general with it. I am going to focus on ones that are probably a little more detailed and that are focused on the operator's actions within that process map, rather than necessarily all of the equipment actions that need to take place. So that whenever I'm looking at ergo or human factors, that's where I'm focused on. Kristi, do you want to add to that one?
Yeah, sure. At times I've done this in the past. I've looked at things like the work procedure and looking at what the worker does with equipment, not so much that, a mixer is running for 2 hours and then they take a sample, but what does the worker do to get product into the mixer, and what equipment do they have to do that? And the example with the fiber drum with the caked up material, I mean, that happens a lot. That's not going to be in the work procedure. And, first I would start off looking at the work procedure or the JSA, and then I'd start asking questions about variations in that, because there's usually something that happens that might not be in the work procedure, that hasn't been identified, just like the caked up material. Well, when it's hot and humid, we have to take this and beat it with a mallet and kick it with our boot and, throw it down on the ground to get it to work, instead of just what the procedure says, which would be to take the powder material and add it to the mixer.
Okay. Another great question here, and I'll let you start on this one, Kristi. So, how do you help people understand when they can stop asking why?
That's a great question. And you know, I've seen this many times. Actually, we started talking about doing a root cause analysis for ergonomics assessments one time in a facility, and they treated it like they would have if we had had just for an assessment. They treated it like it would have been like if we had had somebody who's seriously injured with a huge taproot analysis. And I guess, you know, we want to stop asking why when we get to the point that we can take action on something. So going back to the example with the forces and looking at the cart is hard to push on the floor. Okay, well, the cart's hard to push. Well, there have to be reasons, you know, why is that? Well, the casters are small, or a lot of times you'll see that the casters are out of balance, or maybe one of the wheels had the rubber has a chunk that came out of it and hasn't been replaced. That's an actionable item. You know, the wheel's broken, the wheel's out of balance, the casters are all different sized. So, you know, why are they different sized? Because we didn't replace them with identical parts. Well, the action would be replace them with 4 identical casters. The same is true for the lack of maintenance. You know, there's a hole in the concrete in the ground. Well, why is that? Well, there hasn't been any maintenance. Why hasn't that been done? And then the floor, you know, you have to have a work order that come out to get the floor fixed. So I guess I would say, you know, when you get to something you can take action on, that's where you can look at maybe it's time to stop.
Yeah, and that's a good reason, you know, back to the slide you presented, Kristi, where you at each stage of the why you put in countermeasure and whether there's a countermeasure there. And the only piece that, you know, you really ask there, did we go far enough, is if we did this countermeasure, are we going to prevent this in future situations? So, you know, does this really get at a full prevention, or is this just a band-aid or an immediate fix to it? So that's the only one, but I would agree with them. People often like to go way into the weeds on whys and go well beyond the stage at which it gave you the necessary fix that you needed to have. You know, because I think the answer I heard at one point was that ultimately every why question would come back to either Big Bang or creation as the why for the answer there. So at some point you do need to stop those whys. Um, so there's the question about, have you ever used causal tree methods? The answer to that is yes. I find them valuable when when my team of people doesn't have any really good spot to start from. Then that becomes a really useful tool to get people just into the process and thinking about those. It's if I've got some of like the risk assessment methodology and, you know, already to focus people on what we're working towards, I don't find those as being as important in that situation as when everybody's just struggling with where to start from it. Um, okay, just um, trying to dispel the myth of a root cause. That is fine. Okay, QR code, if the QR code isn't working, our email addresses are up here right now. Email either one of us and we'll make sure that you have a copy of the presentation. What do I think is the minimum number of people? I don't know. I mean, I've done them just by myself. I don't think it works as well as when I have like 3 to 5 people engaged. I usually worry more at the other side of when do I have too many people and I can't get either good discussion because there's too many people, or can't get to any consensus about which line should go where with people because we discuss everything to death in the meeting. And that usually happens somewhere, depending on the people you have, at the 8 to 12 range of people. So I'll set more of a max number that I've had effective with rather than a minimum number. Yeah, a web of causation. I totally agree. And that's really what we're trying to get at with these different ones. Oh, job rotation and how that impacts ergonomics is worthy of a whole nother webinar with it, because it also gets tricky when we look at what the risk factors are in the job itself. So if we're looking at something that has a lot of high forces, particularly, job rotation is going to be considerably less effective than if my issues were low force and high repetition, and I'm able to get rid of some of that repetition through the job rotation. I'd still rather do it through engineering controls, but yeah, that's a much broader one than this. Yeah, if cart maintenance was the issue, why it wasn't maintained is the critical question that comes into play there, as opposed to if the problem was the size of the casters from the start. Yes, we can fix those casters. It may be important to me as the process lead for ergonomics to understand why did we have too small of casters from the start, and how do I prevent that in the future? So I might dig deeper than that for overall programmatic reasons, but for improving that job, that would be the spot I would start at. Yeah, the response, why 5 whys? Because usually you're there. Usually you get to at least one root cause by the time you're at 5 whys. And yes, that's usually the case. If anything in ergonomics, I would say it's rarer that we have to go all the way to 5 than that we're going beyond 5, unless you're really, really getting off into the weeds with it. So, all right. I think that hit all of the questions that we had during the session, and I'll just wrap up. One of the key takeaways for me in developing this is that I think particularly fishbone diagrams are not used as extensively for looking at ergonomics as they could be and that you would have benefit from. And that's really one of the reasons that I wanted to spend time going through that and showing some examples with it, just to identify some other opportunities with it. And I really like that Fishbones do a nice job of getting people to the multi-causality that is typically involved with it, where it takes a little more concerted effort sometimes to get there with 5 whys. Any final thoughts, Kristi?
No, I didn't have anything. Thank you everyone for attending and the great questions and interaction. And thank you for the AIHA for having us.
Okay, great. Thank you both, Rick and Kristi. I also don't see any more questions in the chat. So if there aren't any more questions, we'll go ahead and conclude today's webinar. My thanks to Rick Barker and Kristi Hames for their presentation, to Velocity EHS for sponsoring today's webinar, and to all of our participants. Please visit aiha.webvent.tv in the coming weeks for information about more new Synergist webinars later this year. Thanks to everyone again, and have a great day.
Oh, quick answer. One question came up while we were wrapping up. So on the digraph, the question was the two numbers, which is which. The first number is how many are going out from that box. The second number is how many are coming into that box. And the number that we're most interested in is how many are going out from the box with it. Just wanted to get that in quickly since we saw that come in during the wrap up.
Great, thank you, Rick. I think we're all set, but appreciate it, everyone.
All right, thank you, everyone. This actually concludes today's Thank you all for attending. The recording will be available at aiha.westbend.tv. We will send all registrants an email tomorrow with that link. And please visit our event calendar to sign up for future webcasts.